In this video, we'll take a quick look at using tuples and case classes to organize your data in Scala. If you work in the humanities, one of the most important things you have to do is get your information organized right. That means if you're saving files to disk, you need to get the right formats, and in your code, you need to identify the best data structure to represent your information. We've talked a little bit about collections in our class, and I want to look in this video at collections, tuples, and case classes. Just to review, collections can be ordered collections like vectors and arrays. These ordered collections will have objects of the same type. All the objects will be the same type, and you can refer to elements in a collection with an index starting from 0. So in this example, if we split a string, the split function creates an array of strings. If we split on white space, we have the function will return in just a moment an array of strings, as it tells us right here, and the size of that array is going to be 2. Tuples are a little bit different. They allow us to create a single object with components that might be of different types. You create a tuple using parenthesis notation and just list inside there the components of the tuple. And you use a dot notation to refer to components of the tuple. And irritatingly, tuples start counting from 1 while arrays start counting from 0. It's the worst syntactic feature of Scala, in my humble opinion. So let's create a tuple that's going to be composed of a string and a second string and an integer. Notice that the type of this object is just listed as tuple, that is parentheses containing string, string, int. And if I want to refer to the first name of the person, that's the first element of the tuple. Dot underscore 1 will refer to the first element. Dot underscore 2 gives me the second element. And note that dot underscore 3 is an int type object. So I've got the tuple as a whole is a single unit. Its individual components may be of different types. Case classes give you a way to define the structure of a tuple. You create a case class and give a name to your newly created class, and you can refer to components similarly with a dot notation, similar to any tuple, but you can use names for the components. So here's an example where I'm creating a case class defining a student class as being comprised of a first name, a last name, and a class year. So let's take a look at how we might do that. Case class is our Scala reserved words that will define this for us, and the convention is that class names begin with an uppercase letter. Then I'm going to list the various components and identify their types. So there must be a first string element, a last name string element, and a class year, which will be an int. I've now defined that class, and I can create objects of that class just by using the class name and providing the values for each of the components. So if I wanted to identify my student, note that the type of this newly created object is student. So the case class is the class that this object belongs to. And I can refer to now components by their identifying names rather than just by number. And those components can be of different types. This has a number of advantages. One of them is we can manipulate the components based on their type. So class year is an integer. I could decide, okay, if John graduates a year early, what will his class year be? I can do arithmetic on the value. If he takes a gap year, he could graduate a year later, and I can work with it the way I could work with any individual object of that type. It's also really useful for type checking when you have potentially dirty data. Here's an example to consider. So we've got an array. We created an array by splitting up a string, but I was heavy-handed when I typed this. In fact, we now have an array of strings that I haven't noticed yet has a bad value for the class year for this student. But if I create just a regular old tuple, I could take the first piece of the array, the second piece of the array, the third piece of the array, and it happily forms a legitimate tuple. It's just that now my tuple is string, string, string instead of string, string, integer. And that could be a problem. For example, what if I wanted to manipulate that? What if I wanted to do something like find out what happens if John graduates, a year early? That's not exactly the graduation year I was looking for. Or that would be really, what if he took a year longer? What if he graduates a year early? It's going to be even worse. I can't do subtraction on strings. So, I could easily get tripped up with dirty data and not understand why. By contrast, if I take the three elements of this array and instead, let's see if I can get this copy and paste to work. Let me define my student type, right? And then create a new student who's going to be composed of the three elements of that array. I immediately get a really clear message. There's a type mismatch. The last component here should be an int. In fact, I got a string. And you'll be able to catch those kind of data problems before they ever get in your way and cause further issues for you. So once you have a case class defined, you can use it like any other class in Scala. For example, you could make a collection of objects in a given class. Let me just copy and paste here a little bit to illustrate what I mean. Let's define a case class for a baseball player that has a first name, a last name, and a jersey number. And I'm going to define a whole bunch of player objects. There we go. And now there's nothing, those are just normal objects. No obstacle to doing something like creating a ordered collection of those. So if I wanted to create a batting order, I might do something like just create the ordered set of those objects. At this point, the nice thing is not only can I refer to who's the leadoff hitter by just using a regular index into that vector, but I can do other kinds of things. What if I wanted to print out my roster by jersey number rather than in their assigned order in the batting order? I can sort by the objects in this vector are all player objects, so I know everyone is going to have a jersey number. Just use the dot notation to refer to that, and I wind up with a collection where they're sorted numerically by those integer values. Or similarly, if I want to find a player by jersey number, I don't recognize the player. Who's the guy wearing number 34? Whoops. There we go. And the answer is the greatest designated hitter in the history of baseball. So you can use structured case classes to raise the semantic level of the material you're working with. It's a better way of ordering and structuring data that you understand than just simple tuples. Good. So go to it, use case classes, and use them anywhere you would use a regular class of object.